everyone, welcome to the live stream. This is Sumrine.
Hi, this is Carlos.
Today we're going to go over how to stream data and make cool visuals with Swim. Scott and the Swim team actually helped us create this. They created it and we just tested and made the guide with them. So we're just going to have Scott talk about it. So we'll turn it over. All right. Hi, Scott.
Hello. How you guys doing?
Good. How are you?
Good.
Awesome. So tell us about Swim and you know how you work with it and just how it works. Yeah.
Sure. So I'm going to share my screen and hopefully be able to walk you through some slides of kind of a high level of Swim application and how Swim application is structured. Mm-hmm. And then we're going to walk through some code. And the code we'll be looking at is the code for the demo we're doing today.
Okay. Oh, nice.
That's awesome.
So, share. Okay. Right. So can you guys see my screen okay?
Yeah, we're just going to pin it real quick so it's bigger, and there we go. Cool.
Yeah, we see the Swim plane right now.
Perfect. Okay, so every Swim application starts with a Swim plane, and it's a Java class that is kind of the top level of everything. You can think of it as the main entry point. Mm-hmm. Every Swim plane contains one or more web agents. And a web agent is kind of its standalone stateful bit of data that is able to act on itself. And so one way that I like thinking about Swim is kind of like a theater. And your Swim plane is a stage, and your web agents are actors on that stage. Mm-hmm. And each actor can be set up to do whatever you want it to do. And those actors also carry around data. And at any time, you can go ask that actor for its data. Mm-hmm. So that is handled through routes. Routes are defined in the Swim plane, and we'll show that in a second here. Our Swim plane defines the routes to talk to the web agents. And so everything happens through these routes. Web agents can also talk to each other. And so several agents can share data back and forth, or whatever you want it to be. And those are handled also through routes. And so one example we have is a greenhouse demo, where in the greenhouse you have X number of devices keeping track of plants. Mm-hmm. And so you have a web agent for every device, and then you have a single web agent that is able to keep track of all of those things all at once. And each web agent basically reports back up to the one, which keeps all of that data. Mm-hmm. And so you kind of create this mesh of web agents. Web agents are also able to write out, since it's in Java, you're able to write out to pretty much anything Java can write to. And so we've done things into HDFS, MQTT, we've written to regular databases, and we can read and write XML and CSV, which is pretty nice. That way you can work with your data that's coming in real time, but also save it out to whatever you need to for later analytics. Every web agent also talks over WebSockets. And so we have a JavaScript Swim client that we use for all of our UI stuff, and then some great UI tools that are able to talk directly to web agents and do charts, pie charts, line graphs, all that kind of fun stuff. And then we also have some examples where we do dots on maps, and you can move the dots around and cool things like that. And it's all based in these web agents.
Okay, quick question. Do the web agents talk to each other via sockets as well, or how do they talk to each other?
Web agents talk. So Swim kind of abstracts some of that for you. Okay. When you're actually in the code, you use commands to talk to individual web agents. Okay, cool. And based on the route that you give it, that defines where that web agent is and how you're talking to it. Okay. And so this is the high level flow through all the things. Mm-hmm. Let's switch over to some code, and I can show you how that actually works. Okay, so this panel here on the left, this is the Swim plane for our matrix demo.
Okay, and just to clarify, every project only has one plane, right?
It can have more than one, but generally speaking, we only do one plane per application. But you can have more than one, depending on how big your application is. Okay. And they'd still be able to talk to each other via commands through Swim.
Oh, okay.
That makes sense.
Okay, so in our Swim plane, this first thing that I'll highlight here is a route. And so you see /sensor/ID. Sorry about my dog.
Oh, no worries.
And so that maps to a sensor agent. On the right side over here is the code for that sensor agent.
Mm-hmm.
And so in that swim route, you see /sensor/ID. That :ID lets us create a brand new agent for any value we pass in on the route for that ID. And we'll show in a second how you talk to that.
Okay.
Web agents are created automatically when you first access them. But once they're running, anytime you access via that specific ID, you'll get that web agent. Over here on the right, this is pretty much the entirety of that web agent. And so what this is doing is for every sensor on the Matrix device, we create a new web agent, and it's keeping track of its latest value and the history of its values. And that's done at the very bottom here. Let me highlight the code. Via this command lane. And so like I was saying, the communication happens through commands. This command lane is what's picking that up. And so inside of every web agent, we also have lanes. And lanes is that endpoint that you're talking to of either where you're sending data in or where you're pulling data back out.
Okay.
And so that's what these are defining is you have a route that's going to be your sensor/sensor ID/latest, and it will have the value of your latest. And so if you're using the Swim Java or JavaScript clients, and you create what we call a link to this sensor, to latest, anytime that value changes, you automatically get that change propagated up via the link. And so the value you're looking at, say in your UI that's using that link, always has the latest value. And so you don't have to worry about so much about keeping track of what's connected and what isn't. So I'll show you that actually here in a second. Did you have a question?
No, this Java stuff is the stuff that actually was kind of hard for me to understand. So it's really nice to have somebody explain it. Yeah.
And it's very different from a traditional application. But once you see kind of how the pattern works, it's pretty easy to set up new agents and set new routes and do all kinds of interesting things. So I'm going to switch over to, this is the JavaScript now that drives our, sorry guys, there. This is the JavaScript that's driving the main demo page that you see here. And what you're seeing on the page is a WebGL objects, just random objects. And what happens is when you rotate the device, we rotate that little object. And then we also draw a graph over that. How that's done is a mixture of Three.js, which is a nice little third-party thing, and then our own Swim UI chart. And so you'll see right here, this chunk of code is what creates a chart. And then we add a single plot to it. We can add two, but I have some crufty code in here apparently. And then we create a Three.js scene, which is all just standard stuff if anybody's used Three.js.
Right.
And then down here is kind of where the magic happens. This is where we create a link back to that sensor web agent that's holding the value for the yaw sensor.
Right.
And so what we do, it's kind of a big chunk of things. We tell it what host to go to. And in this case, it's going to be probably our local machine. And then we give it a node, this is that route that you saw on the plane. And this is its ID, is just yaw. Okay. And so every single sensor has an ID and this is where you would put that in. Okay. And then it's grabbing the history lane, which over here, that history lane gets populated automatically by the command. So anytime a new value comes in, it puts in the latest, and then it appends it to this, what we call a map lane in history. And that map lane is sorted by timestamp. And so you always get it in order.
Okay. And that's what gets pushed to the graph?
So yeah, that's how we were drawing the graph is we open that link to the map lane, we're getting all the values coming in, and because we're using our own built-in Swim graphing stuff. All we have to tell it is that endpoint, and it knows how to draw it.
Oh, nice.
Which is really cool.
Yeah,
It saves a lot of time in setting up this kind of stuff. We have. Do I have it open? Nope, color picker. Sorry about this. Let me open another page here. I thought I had it open already. This page is showing every single sensor on the device in real time.
Yeah, it might be a little hard to see because it's dark blue on black.
Yeah, but it's all right because we'll show it again.
Oh, yeah, that's better,
much
yeah.
And anybody that downloads this and runs it on their device, they have these same pages.
Yeah.
And accesses them the same way. And so this is a great example of every single one of these charts is an individual web agent, and it's showing its history lane and its current value lane.
Okay.
And again, all of it updates in real time because that's the core of Swim, is basically shoveling all this data through in real time to whatever you need it to go to.
Okay.
So yeah, that is the kind of high level of how all of that comes together. When we run the application itself, I'm going to drag up two windows here. These two windows, and I'm sorry the text might be really small. I can't make it bigger.
Are you on Windows? Oh, okay.
Yeah.
I don't know how Windows works. How you zoom in on Windows?
I don't think I can enlarge. Yeah, I can't enlarge.
Well, if you right click, I think there'll be like a profile on the top of the title bar.
Oh, I see what you're saying. Yeah.
Yeah, properties, and then you can go to font, and that'll let you increase the size.
I see. Okay, very nice.
Wow.
Oh.
That's funny.
Yeah. I think it'll be fine like around 20 or like around there.
Good. That was good.
Okay. So we'll start with, oh crap, come back. I just lost the window. Oh, come on, Windows.
Do you have another screen?
Okay, so right now I'm SSH'd into the device, and I'm sitting in the bridge directory of the project. The bridge side of things, and actually I didn't talk about that, and that's kind of important. So the bridge is just basic JavaScript that runs inside of Node.js, and it has one job. It picks up the data from a sensor, and it gives it into Swim. And that's all it does. And so it's using your guys' Matrix Light library to query those sensors. And just as a quick example, this is how it's sending the IMU values over. And so we're using our Swim client to send a command back to our server at that route to the command lane itself. And then we just give it whatever the value is. And command lane, we pick it up and all that automatic stuff happens.
So is the bridge section for Swim projects, is that always Node.js, or can it be swapped out for a different language?
It can be anything you need.
Oh, okay.
We've done bridges in Java, JavaScript, and Python.
Nice.
But it's really anything that can open a WebSocket and send commands over a WebSocket, or that can use the Swim JS or Java clients.
Makes sense.
Oh, okay.
Yeah. Cool.
So yeah, that's the bridge part. To start it up, it's just Node bridge. However, you want to start the server first. Let's see if I can not mess this one up. Properties, 36, dink. All right, Matrix 1 server. And so the command we use here is just Gradle run. And this is a brand new machine, so I'm not sure if this will actually work. But ideally, it will compile Swim for you, and then you'll see some debug output, and eventually it'll say run. And at that point, the application's up and running.
Right.
And you want to wait until it says it's running before you start the bridge. Otherwise, the bridge gets mad that it doesn't have anything to talk to and crashes.
Yeah.
I need to fix that bug.
I mean, it makes sense. Like.
Yeah. Well, it should handle it a little more gracefully. Maybe
like
wait a few
around.
seconds and treat it again, and not just like die.
Yeah.
Okay, so you see Gradle's building some stuff, and now we're running. And so you see it says running matrix plane. So we can go over here, say node bridge, and Hopefully it will just start and not crash. Oh, I think I might have. Oh, yeah, I think it's running. I just have the color picker thing turned off.
Okay.
Crap, which I now I lost the color picker.
The color picker one is also a nice one.
Is this part of Swim's features, or did you use like an external library for it?
For which part?
For the color picker, did you build that yourself, or was that already like built?
Oh, yeah.
Oh, nice.
No, we used Swim UI components and JavaScript and just vanilla JavaScript. And so like this clickable part over here is just a canvas, and so when I click, you can see the color change. And all I'm doing is writing an image to the canvas and then reading the RGB value of that pixel when you click on it, and then we send it back into Swim. So really, really easy.
Nice.
Yeah. And hopefully really easy for people to look at and pick apart and do fun things with.
Yeah, I think like that, like once the demo was running on my Pi, I was like, all right, now to like look into the files and see what I can actually change and visibly see something happen, you know? So yeah.
Yeah, the color picker is my favorite.
Yeah, the color picker is visual, so it's really fun. But yeah, so, okay, I think that was a really good explanation, and at least like lets people know which files they can mess with to get started with doing their own thing.
If they have questions, of course, they can reach out to us. We're on social media, on Twitter or Swim, and actually, I don't know what all our social media is, but it's on our website at Swim.ai. And then we also have from there, you can get to our documentation. You can get all our social media, our documentation stuff. And so, yeah, if you have questions, please feel free to reach out to us.
We actually have a question on the live chat from Sean. He's actually on our team. He said, how do you acknowledge your messages with WS? Is that WebSockets?
Okay. WebSockets.
Okay.
So when you're talking over WebSockets, under the hood, we have a language that we developed called Recon. That is kind of a subset of JSON, but with some extra stuff specifically for Swim. And so all messages go over that WebSocket using Recon. And actually, I can try to show you that real quick here. And so if you're not using Swim clients, you would be processing those Recon messages. And it looks... Stop spewing stuff. There we go. So if you look over here, all that stuff scrolling by are Recon messages coming from Swim into the client.
Oh, can you make that a bit bigger?
Might be hard. I don't know.
I don't think I can do that. Yeah, I can't do that with Visual Studio Code.
Yeah.
I see.
I'm sorry, the developer tools.
Oh, developer tools. Yeah.
Oh, it does work.
Oh, cool. Like, was it just slow?
Nice.
Okay, nice.
Yeah. Okay, so yeah, this is each one of those is a Recon message coming over the WebSocket between the server and the client. And so if you're writing your own client, say in Python, you would be parsing these messages and sending them back.
Okay.
But like I said, our Swim client handles that for you, and so you don't have to worry about the details of Recon. You're just focused on the data.
Okay, yeah, because like your API just makes it easy to like communicate back and forth. With nice. Okay, yeah. So, so do you have like anything else you'd like to share with our viewers before we go on to walking through the guide step by step?
No. If you guys have any questions or anything, otherwise, no. I think I've covered all of it.
Yeah, that's awesome. Well, do you have any questions?
No, I mean, I was gonna ask about Recon, but it already got covered. But
yeah,
it's all good.
Okay, awesome. So everybody, like, definitely like reach out to Swim or comment on this video, and we'll make sure the Swim team gets your questions.
Yeah, if you send us any links that you want us to add in the description for how to reach out to you guys, just let us know and we'll add them to the video. Yeah,
we'll add them to the video. And we'll add all the Swim resources, and thank you so much for your explanation. I'm sure it'll be like helpful for a lot of people.
I think we have all the links also in the README for the GitHub.
Okay, awesome. Yeah.
Nice. I'll also link that as well.
Yeah, we'll link the GitHub. Okay, awesome. Thank you so much for your
thanks
time,
for taking
Scott.
your time.
Yeah,
thank you.
We're just gonna go over the guide now, so people can hopefully follow that. Yeah. All right. Well, have a good day.
All right. Bye.
You too.
Bye. All right. Let's see. All right, so I am going to quickly get our side camera back on so people can see us, and we'll get started with the guide. So here we have, all right. So I'm not sure if everybody can see this. It doesn't seem to be showing up. Oh, I just got rid of, never mind. Sorry, everybody. Haha, I just got rid of everything instead of putting back our video. All right, well, apologies for the little glitch I had there. Yeah. All right, so we're gonna go over the guide. It's gonna be really quick because
so this is what we just went over with Scott. We're just gonna show you how to set it up for either Raspbian Stretch or Raspbian Buster. We got to work with both, and yeah, that way you can just set it up and play around with the code and fiddle with whatever you want.
Right, so this is exactly our Hackster guide, and we're just gonna walk through it step by step. All right, so first, required hardware. Obviously, you have to have your trusty Raspberry Pi and Matrix Creator or Voice. Once we get like a mic demo, like mic data streaming demo running, then you could also use a Voice. But today we're gonna do it with the Creator since we have sensor data streaming at the moment. All right, so let's get started. You install Git if you don't already have it. Let me make this a little bit bigger. I don't know if people can see the text. So I already have this installed, but just for the sake of having all the steps on the video, I'm gonna click on that. Git is already the newest version. For you, it'll most likely install it. And then you clone the Swim repo. This is a really straightforward guide because Scott from Swim actually made this setup script that, like, you just run the setup script and it installs all the dependencies you need, so you don't have to worry too much. And then you enter the directory.
Yeah, it handles all the Java setup for you, so no need to worry about the environmental variables.
Also handles the Node.js installation because it needs a specific version. So this is just us entering into the directory. And then you have all of the setup file, the running bridge, running Swim, all those files. So we're just gonna make them executables real quick, just in case they aren't already, as now they aren't. All right, so enter. I'm gonna clear and go back up so that our video doesn't cover it. Okay, so as you can see, the color for these have changed because now they're executables. Okay, so this is the Raspbian Stretch workaround. I am actually on Raspbian Buster. The way you can check if you need the workaround or not is copy paste this command if you're not sure if you're on Raspbian Stretch or Buster. And it tells you like, okay, I'm on Buster, this is a release, blah, blah, blah. So I don't need to do the workaround. It's really simple. You just copy paste these commands. So at first you add the backport, the Stretch backport, repository, I suppose, or where it's hosted, into the list so that it can update and pull from that, as far as I understand. And then you have to add the keys, because the license keys and stuff like that, or GPG keys. But very simple. You just copy paste these commands one by one and you should be fine. I'm gonna move on since I'm using Raspbian Buster. Setup prerequisites, all of them will be installed with setup.sh. Because this takes a really long time to run, I actually already have this done in another, so I would press enter and it would install a lot of stuff. I'm just going to Control-C out of it because it just takes really long.
Yeah, I got it.
It is super important. This step I forgot earlier when I was setting it up. And if you forget this step, your bridge won't work. So in this setup script, you're installing Matrix HAL, which is the hardware abstraction layer, and you're installing all the Matrix packages. For your Matrix creator to be realized as a creator, you have to reboot the Pi so it can flash the FPGA on the creator. So you have to do sudo reboot after this step. So I'm gonna go ahead and reboot. And you just wait a few seconds.
Yeah, it'll take maybe 15-ish seconds.
And then you SSH back in. So let's see, SSH. I guess I didn't wait long enough. It'll be back in a sec. So once it's back, you can. Is the light coming on?
Okay. Hold on. Okay, wait. Try now.
All right. So SSH, there we go, password Raspberry, unless you've changed it. And cool. So now I'm going to go into the Matrix1 repo that I already have all the setup done for.
Yeah, so this is the Swim project repo.
This is the Swim project repo, the one you cloned earlier. This is what you go back into. And then now you're going to run the run swim executable. So paste that. Oops. I didn't copy the whole thing apparently. // so you can run it, starting swim. So then you copy this this command right here. It basically spits out the log file and error file output. I'm going to clear so you can see it. And so you see it starting a Gradle daemon.
Okay, so just to clarify, when you do /run swim.sh, it runs a background process of the Swim server.
Yes.
And then right now we're looking into the logs of that server.
Yes.
Okay.
Very, very nice. Yeah. Nice clarification. So when you're first doing this, because I already did this before, you're going to actually have some more output here. It's going to say like downloading Gradle. It's going to take a little bit longer for it to start, but you should keep an eye on this till it says, until all of this stuff is done, and it'll say running Matrix1 plain. Just like it says in this image
right
at the end. Yeah. So once it says that, if you go to your browser, you type in HTTP, your PI's IP :9001, you will see the bare bones, like this is JavaScript, most likely like a web interface. I'm trying to find the right words. All right,
You
so
can just call it like a web app.
Web app, yeah. So once you see that, you're like, okay, I'm ready to run the bridge. And the bridge, as Scott had explained earlier, is basically the bridge between the sensor data or whatever data from your device that you are piping into through
Well,
Swim.
I mean, it's a bridge between the creator sensors and Swim.
And Swim, right? That you're piping into Swim. And that visualization will appear.
Yeah, so right now we have the server running, and everything's running there, but because we don't have the creator's data being sent, it's just going to be empty for now.
Right. So we're going to Control-C out of the logs, like it says right here, and we're going to run the client side, so the bridge. So that's just /run bridge.sh, Command-V, and similar to, so this should run the client side. Actually, you can already see it working because the LED on the creator will instantly start moving like this. If we go to the Swim page on your browser, you'll already start seeing data. But you can also see the error logs. If you don't see anything, you can see the error logs and what's going on by typing in this command. Basically, this is the same thing as the tail-f swim.log.
Yeah, so just like you're seeing the server logs, now we're seeing the bridge logs.
Yeah.
And ideally, if you want to see both at the same time, you'd open up two SSH sessions, and then put both tail commands in each. That way you can compare with both.
Yeah, I think you might even be able to put like all four like files in there, and it'll just show you the output of them all. Like,
well, that probably wouldn't be ideal.
Yeah, I mean, it's not as nice, but yeah, it tells you all of it, but it's not as nice, as pretty looking. But yeah, definitely the log files and the error files are super nice for debugging. It was really helpful when debugging. All right, so that's it. That's setting up Swim. So we'll just go over, like Scott already went over some of this and when he screen shared, but we'll just go over it real quick. This is a gyroscope visualization, which is like when you move around the creator. Well, actually, this is the yaw, so it actually doesn't use the gyroscope. I should update the guide. It actually uses the magnetometer. So yaw uses the magnetometer, and it's going all the way around, and it's mapping the angles and degrees. It has quite a bit of noise. We're working on improving the yaw sensitivity. But yeah, it's a cool visualization because the creator moves around and then the visualization moves around. All right, the other one that Scott was showing that is super cool is the /sensors.html page. And that one shows the live logs of the sensor data. It seems to be a little bit glitchy right now. Let me see. Let me keep an eye on the error logs just in case.
Could be that our connection on the web browser is a little slow.
Yeah, our connection might be slow. We are running a live stream as well. So, all right. So as we're moving it, okay, let's look at an easy one. I'm gonna command ++. Oop,
Actually, go to UV. That should be easy as well.
UV? Oh yeah, UV should be easy. Where'd UV
Is it there?
go? Yeah, they definitely have UV in this list. Altitude. What? Wait, never mind. I don't see UV, but we can put UV in here. A fun one that we could just look at for now is like pitch or roll. So this is pitch. If I go all the way here, it should be close to 90. If I go all the way here, it should be close to negative 90. As you can see right here. Yeah. So close to negative 90, and then all the way here is close to positive 90. So there we go. Proof that it works. All right, and then finally, the most like visually fun one for me is the color picker. And all of the different URLs are right here and like what they point to, so you can see. And the color picker is super fun. I'm gonna make it bigger. And so this is the one that we gave everybody a sneak peek of. But using this, I guess hue or I don't know what
color wheel.
Color wheel. Okay, yeah. Using this color wheel, you can change colors. Let's see. Is it changing?
Yeah.
Okay. Yeah. The stream has a delay, so it confuses me. All right. So it changes the colors. You can also manually change them. If this is too bright, you can make it less bright. Mess with the colors. You can slide. You know, I'm just gonna turn them off for now. But yeah, it's super cool. So just have fun with it. Edit the code. Let's see.
It's kind of funny when you turn them off. It's still spinning around the LED.
Oh no! What did I do? Oh yeah, when I turn it on, it's off. It's still spinning around the LED. It's just like no longer has a color.
Yeah, like the logic's still going, but the color is nothing.
Right. Just before we end, I will show you how to stop everything, and that is a super simple command. It's literally the /stopall.sh. Copy that. I keep forgetting that I'm not on Linux, and I'm trying to do the hotkey.
Yeah.
Okay, so Control C, Command V, and whoops. Oh.
Capital A.
Oh, I'm gonna edit the guide. Sorry, peeps.
Yeah, and if you want to know exactly what these commands are doing, they're just shell scripts, so obviously you can just open them up and take whatever commands you want out of there. Exactly. But we provide them here. Scott provided them here as well as with the Swim team to just make this a lot easier.
Clear. So here, let's look at what's inside stopall.sh, for example. It's literally just kill all Java, kill all Node, you know? So, well, I mean, maybe you won't want to use this if you have other Java or Node stuff running in the background. I don't know. Well, actually, it is in the path, so it probably wouldn't kill everything, right? Actually, I'm not too sure about the syntax. I'm pretty sure it only kills things in this directory. But yeah, so you can always look inside and see what's actually going on. But the scripts make it super easy, right? All right, so yeah, that's about it. And then there's a little bit of like text about how to build off the example. It tells you very
so what we just went over, like what the bridge is, the server is, and there's also some extra stuff like templates and a little bit more into like the UI. I mean, not much, but just right there.
Yeah, just telling you like where they are. And then as like Scott was talking about, you should check out the portion of his video where he talks about the planes and the agents, and that might be helpful. And yeah, personally, I thought like a good place to start would be like the LED animations, because that's something you can like mess around with. And then definitely check out their website and tutorials, and they have a bunch of like ways you can get into. Yeah,
they have documentation for both the front end and back end of Swim.
Yeah, and then there's an enclosure here that Scott designed for fun, so that's super cool if you want to check it out. Something.
Actually, show it up on the.
Yeah, definitely gonna show it. It's super cool. I think there's two different versions. One with like fin-looking things.
Yeah, and the other has hexadecimals. Oh, sorry.
Hex shapes.
Hex
let us know if you have any questions while we're like showing and loading these things, and then we're just gonna end the stream. And then this is the GitHub. Right? Yeah, this is the GitHub. So also check out the GitHub. The GitHub README also has all the links you would need.
Yeah, we'll have it in the video description as well, and this has a video of a bit more into the logic, as well as some useful documentation links for like Swim, how to contact them, and all that.
Yeah, and look, these are really nice pictures. Wow.
Yeah, the enclosure is for the Matrix Creator. Yeah. The enclosure is for the Matrix Creator, and it's really nice. It has has some holes around the side to aid with
Vent,
the cool.
yeah, I
some
guess.
vents, as well as a little LED ring cover. So if they get too bright, you can at least cover them and diffuse the lights a little bit.
Yeah, super nice. So definitely, if you like 3D printing and stuff, like check out these cases. They're super cool. All right, so I guess that's it. I'll go back to the front and we'll close out with some really quick announcements. All right, so thank you for watching. If you have any questions at any point, post on our community, post comments on the video. We will respond at some point, definitely. And announcements wise, we'll keep it short. Our SNPs contest, voice AI hardware contest winners were announced this Monday.
Yeah.
So super excited about them. Please check out all the cool projects. People put a lot of work into it. It was super fun to go through them all.
Yeah, also Matrix Lite Python was released, so you can program NFC on the Matrix Creator with Python if you want to try that out.
Yeah, definitely try that out too, and let us know if you have any suggestions or things like that, right? Always love feedback. And last but not least, we have ARM AIoT coming up December 2nd to 3rd. We'll be in Mountain View, California for it. So if you're around there or going to the summit, just come hang out, come to our workshop. We're prepping for the workshop right now, right after this live stream. So, all right.
Yeah, I think that covers everything.
Cool. Thank you for watching.
All right. Bye.
Bye.